Let's now look at binomial coefficients. So looking into this, by definition, it says for any non-negative integers r and k, with r being less than or equal to k, this form works. And this is where the k has over r minus 1 plus k over r would end up being a k plus 1 over r. Now, for our purposes, this is not absolutely necessary to know for applying the binomial theorem in this course. So as we're looking at this, let's go back, and we had Pascal's triangle to find the coefficients of an item. And when we expand, now we're going to learn a second way of finding the coefficients. And this is called binomial theorem to find the coefficients of an expansion. So instead of Pascal's, there's binomial. There's two methods, and you'll need to know both methods for the exam. So let's begin. I find that if we look at this and do an example, we're a little bit better. Remember the expansion? When we expanded that the first term is to the power of whatever the nth power is, then it goes down by 1 each time until it's gone. It'd be a to the 0 down here. And then the b value goes up. And you notice that there's no b showing because b to the 0 is 1. And then it goes 1, 2, and so forth. Now, the coefficient, the binomial theorem for coefficients, basically takes just the nth power, so whatever the nth power is, over the position. Remember, we're going to start at 0, though, and then go 1, 2, 3, 4, all the way up until we get to whatever the nth position is. Now, remember that the nth position here is 4. That means we should have 5 terms in that. It's always one more than its power. So let's begin. If I take x plus y to the 4th, my binomial coefficient would be 4. That would be how many we have, the 4th item, over 0, times, remember this is your a and this is your b, your a value to the 4th, so that would be x to the 4th, and then the b values to 0. Well, anything to 0 is 1. I don't have to put that there. You can if you want, it's optional, but I'm going to say no, and I'm going to move on. And then my next one would be, again, the power, the expansion over the next position would be 1. And I would have, again, x to now the 3rd, and then y would begin, y to the 1st. Now, I'm only showing it in parentheses right now because what if this was a 2x plus 4? Well, the 2x would go in with the x, and you'd have to cube the 2 as well as the x when you start to reduce it down. That's why I put it in parentheses to start with so I don't forget. And then the next one would be 4 over 2, and we would have x squared and then y squared, and then plus 4 over 3, and we would have x squared, or excuse me, x to the 1st. Where's my lovely whiteout that I wish I invented a long time ago, because I use it all the time because I'm human. So x to the 1st, and then y to the 3rd, plus 4 over 4, and then my x to the 0 is 1, so I'm not going to put it there, and I have y to the 4th. All right, now how do I find those coefficients? I need to reduce down any pieces that I need to do. I'm going to do a couple of them just to show you. So say I want to find, let's look. Let's actually do the first one, 4 over 0. That, if you remember your factorial from the previous video, we have 4 factorial over the bottom piece would be 0 factorial times 4 minus 0 factorial. Well, if you think about that, this is going to be 4. And if you actually plug it into your calculator, you're going to end up with a coefficient of just plain old 1. Try it out, do your math, and see what happens. Now let's do another. And that's going to be, let's do 4 over 2. Let's do that one. So maybe I'll do this one. This is going to be a 4 factorial over 2 factorial, and then 4 minus 2 factorial. Well, on your exam, you're going to need to show work and not just say this equals whatever number. You have to prove to me you know your factorials. And then you also need to show a little bit of work. So what this does, and this is the same as 1 times 2 times 3 times 4, or go backwards is typical, 4, 3, 2, 1. That's how they normally list them in the books. And then this is going to be 1 times 2, but this is also 2 factorial. So it's 1 times 2 here as well. And then I go, okay, these all divide there. You can do 12 divided by 2, or you can reduce first, but that one's really easy to see in your head. And I would get this to be a coefficient of 6. Now, again, maybe I'll do one more. And you would be, 4 over 3. I almost put a division. But you would do the same thing for each of these coefficients. So I would have that equal 4 factorial over 3 factorial. And then what's 4 minus 3? It's 1 factorial. So again, we are back to 1 times 2 times 3 times 4, or the way the book normally does it. And this is 1 times 2 times 3, and then this is 1. And we would have that end up being, on this one, is going to be, look at reducing it. If you want to quickly do that in your head, of course you can, and you get 4. So after you've done all of them, our final answer would be what the beginning piece asked. It's x plus y to the 4th equals, this is the coefficient of the first term, or the first term. So it's 1 times x to the 4th. Okay, plus this one ends up being 4. So that's one I didn't do. So it's 4, and then I have x cubed y. And then I did do this one at 6. So it's 6 times, go up here. This is the this second, but it's 1, 2, third term. And we would have x squared and y squared. And then I go to the next one, and that's this one. So plus 4xy cubed, and then plus 1y to the 4th. Now, you may ask, oh, it's much easier to do Pascal's to the power of 4. It would be. But a power of 20, a power of, or an n value, anything large, even 15, would not always be the best to use Pascal's, because then unless you have more rows memorized, it'll be much more difficult. I recommend the higher the number, I tend to go to the binomial theorem instead of Pascal's, but if it's a lower one under 10, I typically may use Pascal's. For your exam, you're going to need to know both and how to use it. So, hope all is well. Thanks for listening.